Okay, all right, so I got it. Turned it upside down there for a minute, but it'll be right side up. All right, so this is August 18th, and we're taking a look at section P-1. All right, so what this is basically, it's going to be review of some algebraic expressions. It's going to go over all your number properties. It's also going to do some absolute values. So a lot of it's going to be stuff you've already seen. All right, there will be a little bit of set theory. Nice little introduction to a couple concepts. That's going to be brand new because you've never seen set theory. And the way that we're going to do absolute value in this, you've never seen the absolute value this way. Okay, so algebraic expressions. All right, I'm only going to do a couple examples. Actually, I'm only going to do one example. All right, this should really seriously be review. All right, at this point, so let's suppose you had something like a 2x plus a y, and then that was over an xy minus a 2x. Okay, so if I want you to evaluate this expression, I've got to tell you what the variables are. Okay, so we're going to maybe say something like when x equals 2 and y equals 4. Okay, so pretty straightforward. This is what you did in Algebra 1. This is what you did in Algebra 2. You're going to take each one of those variables and you're going to replace them. And then order of operations, since this function is a rational function, all right, looks like a fraction. So it's a rational function. It has a top and a bottom. You're going to do order of operations on the top. You're going to do order of operations on the bottom when you plug things back in. All right, so 2 in front of that x means 2 times. Replace the x with 2. All right, plus replace y with 4. All right, and then x times y, so 2 times 4 minus 2, replace the x with a 2. All right, on that first step, you really seriously ought to plug everything in and try not to do any of the math in your head. I know it's relatively simple math, all right, but a lot of times the mistake you make first is just you simply plugged in the wrong number for the wrong variable, okay? All right, since this is a quotient, 9 times out of 10, I will always show my work going down the paper. Okay, however, this is a quotient. Quotients sometimes lead themselves a little bit to go sideways. All right, so order of operations on top there. I'm going to have 4 plus 4. 4 times 2 here is going to give me an 8. 2 times 2 is going to give me a 4. Across the top, 4 and 4 is 8. 8 minus 4 is 4. Now I can actually divide right there and get an answer of 2. All right, so there's going to be, in today's homework assignment, there's going to be lots of algebraic expressions like that. They're not going to be the real simple ones. They're going to be a little bit more complicated. I would say this is a little bit more complicated than in Algebra 1 and Algebra 2. Okay, but still something you can all do, right? So we're good with this. Okay. All right, let's go to a concept that they throw in here that's new in this first section. All right, they're going to give you just a nice little introduction to some set theory. Okay, so there's 2 main concepts in this section that they're trying to introduce you to. All right, one of them is something that's called a union, and the other one is called an intersection. I'm pretty sure this is all brand new because it wasn't covered in Algebra 1, it probably wasn't covered in Algebra 2. All right, there are 2 mathematical symbols that represent both union and intersection. All right, it's going to look like, when I draw it on my hand, it's going to look like a U. It is not a U, all right, but it is an upright symbol like that. When you look at it in your textbook or you see it typed in a math document, you'll be able to tell it's not a U. It is like an upright symbol like that. Intersection is the same thing, but turned upside down, okay? So in the book, you'll be able to definitely tell those. All right, now I'm going to describe what those 2 things mean. I'm going to use Venn diagrams. Okay, you did Venn diagrams in English and other classes. All right, when you union something, just in general definition of the word, you put it together, right? You union, you put it together. So if I had a set A here and then I had a set B here, all right, if I union this together, I'm going to have everything all together. Okay, so the whole thing, the whole Venn diagram would be shaded together. All right, for intersection, all right, think of it just like an intersection in streets. Two streets intersect, and then you have an intersection. All right, so if I had a set A and I had a set B, All right, the part that overlaps or intersects is right there in the middle. Okay, so there's your intersection. Okay, just to conceptually understand. All right, now what we're going to do with these in math is we're going to, in this book, they're just giving you a nice little introduction. You're going to do it with sets. Okay, now your sets can have numbers in them, they can have shapes in them, they can have words in them. It doesn't matter what is in our set. Okay, for an example here, I am going to do sets that have numbers in them. So let's say set A here, I'm going to use some set brackets because it's a set, has 0, 1, 3, and 5 in it. Okay, and then let's set B, maybe has 0, 1, 2, and 4. Okay, so they've got to give you the sets initially. And then, like I said, I don't have to have numbers in there. I could put words inside that set. I could do shapes. I could have drawn a circle and a square and triangle inside there. Anything can be inside my sets. All right, what's inside here are called the elements of the set. All right, so those are the elements of the set. That's going a little bit farther into what this section does, but they're elements. They're the elements of the set. Okay, now from there, they can ask you to find, maybe say A, and then the mathematical symbol that represents union B. Okay, so A union B. So in other words, we need to take set A and set B and put them all together. All right, now they both have 0, they both have a 1. You're only gonna, when you put them together, you're only gonna write 0 and 1 one time. Okay, but basically I got to include everything in set A and I got to include everything in set B for a union. Okay, so 1 is in both of them. I'm combining here. 2 is in both of them, or 1 rather. 2, all right, because I'm combining them together. I'm going to include a 3. I'm going to include a 4. I'm going to include a 5. And I write the answer as a set. I took 2 sets and I combined them. Okay, so that right there is my answer. All right, now let's do same set A and B so I don't have to rewrite and make new sets. Okay. Let's say we want to find A intersect B. Okay, we want to find A intersect B. So I want the intersection. So in other words, I want the part that overlaps, or I want the numbers that appear in both sets. Okay, so the numbers that appear in both sets are 0 and 1, 0 and 1. And when I ask a question like that in class, and you guys, normally what I do is I ask it just rhetorically and anybody just yells out the answer, except no one's yelling and we all have masks on, so I can't hear you. So this is, I don't know how this is going to work. Yesterday, I couldn't hear anybody in the room that answered me. So yeah, I don't know how this is going to work. We'll just keep going with it. Okay, so 0 and 1 are in both of them. I want the intersection. Okay, so I'm not going to do tons of examples of these. I think it's a relatively easy concept. There are 2 basic concepts in set theory that they're trying to get you used to here. All right, but like I said, my example had numbers. In the book, as your homework, you're going to see letters as your elements, and you might see words. Okay, you can also see words. Okay, now let's do a little bit more. You might encounter, let's do some vocab here. You need to know what the empty set is. Okay, there's something called an empty set. It can also be called the null set. Okay. Symbols, mathematical symbols for that. You could do something as simple as a couple set brackets and not put anything in it. That would be an empty set, a set that is empty. It doesn't have any elements in it. Okay, or a circle with a line through it also means the empty set. So either one of those would be considered mathematical symbols for the empty set. Okay, now let's do an example. All right, let's do something with letters here, just so you can see something different and everything's not just numbers. let's put C-O-W. All right, even though it spells a word, all right, they're just random letters. So that set right there consists of 3 letters, 3 elements, C, O, and W. All right, now let's say that we're going to intersect that with the set that is boy. Okay, so again, yes, I spelled out a word in there, which is what your book does. Makes it a little bit more confusing. But basically all this is a set that's got 3 elements in it. They happen to be letters, B, O, and Y. Okay, now if I'm intersecting, I want to know what the intersection is. The intersection is the letter O. Okay. If I would have wrote the word girl, if this set right here would have been girl, the intersection would have been the, if I had girl right here, add that to the problem. If instead I had girl, what's the intersection of that if I did girl? Nothing, empty set, null set, so I could just do something as simple as that. Okay. All right, I think that's somebody wanting in. Oh, there we go. Okay. Okay, we got him in there. Okay. All right, so far so good on that. That's all new concepts. All right, but just a nice little introduction in this section. Okay, now let's go over your real number properties, because those probably you're going to not have remembered those as well as some of the others. You did your real number properties in Algebra 1, and then hopefully you redid them in Algebra 2. Once I start going over the properties, you're going to remember them. Okay, and I'm going to shorten it here. I'm not going to write the whole entire thing out, but there's a property called the commutative property of addition, the commutative property of multiplication. So I'm just going to write commutative. All right, you should indicate whether it's of addition or if it's of multiplication. All right, the way my clue word for helping you to remember what commutative is switching. So in other words, when the numbers have been switched around, if I'm switching the numbers around, then I've got commutative property. All right, and you do know this, right? If I take 4 plus 6, that's the same thing as 6 plus 4. Okay, now this one is the commutative property of addition. All right, and when you do this in Math Excel, it literally will write the entire title out for you. It's going to say commutative property of addition. Okay. On your homework, if you're looking at this and you've got to write down on your paper what property that is, I will let you write commutative and abbreviate it, and then put a little plus sign after it, because then that's telling me it's a commutative property of addition. Okay. Obviously, I'm not going to do 2 examples for everything, but could I also do this with multiplication? Can I multiply numbers in any order? I can, right? So 2 times 3 is the exact same thing as 3 times 2. Okay, so again, this one though, if you were going to write down the answer, you would say it's the commutative property of multiplication. So you put a little time sign there. Then this just allows you shorthand notation so you don't have to write out the name of the whole property. Okay, another property that hopefully you remember is the associative property. Again, I'm not going to write the whole thing out. It's the associative property of addition, associative property of multiplication. My clue word to help you remember is regrouping. If the numbers have been grouped together in a different order. Okay, if the numbers have been grouped together in a different order. Okay, so one key thing here for associative property. I'm going to have something on the left-hand side of the equal sign. I'm going to have something on the right-hand side. The numbers on the left need to be in the same order as they are on the right. So if I do 2 plus 3 plus 5 on the left-hand side, all right, then the numbers also have to appear 2 plus 3 plus 5 on the right-hand side for associative. But this regrouping idea means that maybe, say, on the left, the 2 and 3 are grouped together, and then on the right, the 3 and 5 are grouped together. Okay, so I'm just reading. Over here, we group together 2 and 3. Over here, we group together 3 and 5. Okay, but the numbers are in the exact same order. So then, yeah, you know it's associative. All right, now this is the associative property. So again, I'm going to let you abbreviate that, ASSOC. It's the associative property of addition. So you got to tell me whether it's addition or multiplication. Okay, now you do need to be careful, all right? If I did, I don't know, let's do 4 plus 1 plus 6, and then let's do 6 plus 4 plus 1. Okay, now you got to ask yourself, have the numbers been regrouped? They've not been regrouped, right? Because on both sides, I've got the 4 plus 1 instead of parentheses. I've got the over one here, 4 plus 1 instead of parentheses. So I didn't do any regrouping. Did I do some switching? I did switch, right? Because over here, 4 plus 1, it comes first, and then the 6. But over here, the 6 came first, and then that parentheses with the 4 plus 1 comes second. All right, so the order has been switched, and it's been switched over the addition. So this one is commutative property of addition. Okay, so that one's commutative property of addition. Okay, so, and yes, textbooks do like to do that. They like to give you problems that look like that. All right, let's see if I can get some more properties down on this side of the piece of paper. All right, distributive property. I really hate when they list it separately, because to me, I view the distributive property as an action that you do. All right, when you're simplifying expressions and you're manipulating equations, you're trying to solve equations, honestly, you do the distributive property all the time, right? Like, so it's an action to me more so than anything. Like if I was going to solve 2 parentheses 3x plus 6 equals 10, which I know that equation is not probably going to come out nice, but you do the distributive property to simplify that equation and solve it, right? You take whatever's on the outside and you multiply it by everything that's on the inside. That's the action of the distributive property. Okay, so 2 times that 3x would be what, 6x? 2 times the 6 is going to be 12. Don't let me make any mistakes, guys. Okay, always, because I do go crazy. So watch my math. Okay, so 6x plus 12 equals 10. If I kept solving, this is a moot point here because I'm solving an equation, but 6x equals, what is that, -2? Don't let me screw up. X equals -1/3. All right, so I used the distributive property in that first step to simplify it so that I could work it out. All right, but that's not how you're going to see it in this section where all they're wanting you to do is identify the distributive property. All right, so what you're going to see is you're going to see maybe something like a 7 parentheses 2 plus square root of 3. All right, and then equals. All right, now they're going to do the distributive property. They're going to distribute that 7. On the right-hand side, you might see the multiplication already multiplied out. So in other words, I might see a 14, because 2 times 7 is 14, plus 7 square root of 3, because that would be me doing the action. And then we know, yes, that's a distributive property. Or the textbook might leave it not multiplied out. So it's going to look like this. 7 parentheses 2 plus square root of 3. They might only show you 7.2, 7 times 2, plus 7 times square root of 3. All right, so just different ways to write it. All right, I'm still taking what's on the outside of the parentheses and multiplying it by everything on the inside of the parentheses. So I'm still distributing. All right, but this is kind of what you're going to see in this section where you've got a name, distributive properties. You would just literally write distributive property as an answer. All right, you can abbreviate it, distributive property, because both of those are distributive property. Okay, so good so far? Okay, we've got 2 more that are in this section. All right, there is the, all right, now I'm going to write down the shortcut abbreviated form of this. I'm going to write down ID plus, okay, because that's going to be my property. Let's write out the full name, though, just so you have it. This is referring to the identity property of addition. Okay, the identity property of addition. Okay, so in other words, if I start with a number, okay, any number, doesn't make any difference. Let's say I start with 8. What can I add to that number to get that number back? 0. Somebody said 0 in the room. All right, if I take that and I add 0, I get 8 back. It doesn't change it. All right, so that means the identity element for addition is 0. Okay, because I can add it to any number and it doesn't change it. Okay, so a property that is written like this, ID plus, you can just write down ID plus as your answer because that's the identity property of addition. Okay, but shorthand answer there. Okay, we also have an ID times. All right, so again, you can write ID times. We'll know what we mean. It's the identity property of multiplication. So that's the formal, great big long word. And again, if you're working this out in Math Excel, all right, they show you a property and then they're going to have the full name. So they will literally write out identity property of multiplication. Okay. All right. Now, again, let's do this. Let's start with some number like say 3. What can I multiply by 3 to get 3 back? 1. So 1 is the identity property for multiplication. All right, so it could look like that. And then if you are identifying the property, you would put ID times. All right, they might do something like 1x equals x. It's still 1 times x equals x, okay? As long as they put the 1 in there, it's not reflexive. If you remember, you had a reflexive property in geometry, okay? But as long as they put that 1 in there, they could get away with that. All right, we could do something with variables. 2a times 1 equals 2a. All right, I did each one of these properties with numbers, okay? But you might see them with variables, or you might see them with a combination of numbers and variables. It's all the same stuff. All right, I was just trying to review basic properties. Okay, not that you have to do tons of this, all right? But whenever we take the first chapter P test, all right, I'll put some properties on there so you have them memorized. All right, so we get the properties. Okay, all right, now we're going to take a look at absolute value, okay? And we're going to do absolute value different than we've ever done before. Okay, so there's a formal definition of absolute value, right? There's a formal definition of absolute value. The distance a number is away from 0, right? You can look it up in the math book. All right, that's officially or formally the way it's taught. All right, but for the most part, what hopefully or probably what you have done is you've just kind of figured out, okay, I'm going to know how to get the right answer. So what you've done is you've done absolute value of 8 is what? 8, right? Because it's always positive. All right, absolute value represents the distance from 0. So how far away from that is 0? So absolute value of a positive number is still positive. All right, so that would be easy things. Absolute value of, say, a negative number. All right, well, I want to know how far away from 0 it is. So positive 3. So as long as there is a single number on the inside of the absolute value bars, it basically makes it positive because it's representing a distance. Okay, now you up to this point, let's try to do a comparison here. Let's do 2 problems that look very, very similar but are not the same. All right, let's say the directions tell you to evaluate. Let's say they give you absolute value of -4 plus 8. All right, versus a problem that would look like the absolute value bars around just the -4 plus the absolute value bars around the 8. Okay, those are not the same problems. They're written differently. You can almost think of the absolute value bars as a set of parentheses because you got to work inside out first. I cannot take the absolute value of this until I am down to a single number. Okay, so work inside there first. What's a good old-fashioned -4 plus 8? Just 4, right? So work inside. Keep the absolute value bars because I didn't do anything with the absolute value. All I did was work on the inside. Now I'm down to a single number inside. What's my distance from 0? Well, 4. Absolute value of a positive number is positive. Now, compared to the way you're going to do this one over here, there's a single number inside both of those absolute value bars. So I can immediately take the absolute value. So absolute value of -4 is 4. Bring down the plus sign. Absolute value of 8 is 8. 8 plus 4 is 12. Okay, so you clearly get different answers. Both of them had a -4 and an 8 in there, but because of where the absolute value signs are, it shows up a little bit differently as a final answer. Okay, now this is stuff you did in Algebra 1. You may have even done this in middle school. Okay, Algebra 2. All right, now you're in Pre-Calc, so they're going to put more, I don't know, let's say more fancy stuff inside your absolute value bars. Okay, so let's say we're going to do absolute value square root of 3 minus 1. Okay, now what I want you to do is, first of all, I want you to think. Okay, you got to think. All right, anybody know roughly what square root of 3 is? Might be a hard one. Something times something equals 3. Yeah, 1.7. I think it's about 1.7, but 1 point something. Okay. All right. So I think it's about 1.7. Okay. So this right here is 1.7, rough estimate. Okay. Minus 1. So is the answer going to be positive or negative inside there? Like if I took the square root of 3 minus 1, estimating this at 1.7, 1.7 minus 1 gives me 0.7. Is that positive or negative? Positive, right? When over here, when I took the absolute value of a positive number, what did I get back? I got the exact same thing back, right? I got my positive number back. So if I know this value inside the absolute value bars is going to be positive, then my answer is same thing, square root of 3 minus 1. All right, no need to turn that into a decimal. No need to like having it, you know, square root of 3, put it in your calculator, minus 1. Okay, just think, use a little bit of your head. Okay. Now go back here. When I took the absolute value of a negative number, it changed the sign, right? Basically, it did the opposite. Now, think about how you would do that. If I had a -3, how could I turn that into a positive 3? Mathematically, legally, could I multiply this by a -1? And then it's going to give me the positive 3, right? That conceptually makes sense to you. Okay. So when I have a negative number inside the absolute value bars, I need the positive value of it. So if it is a negative number in there, well, if I take whatever's on the inside, which is negative, and multiply it by -1, I don't change the value of it. All I'm doing is changing the sign of it. Okay. Now, thinking that, let's do absolute value of 2 minus pi. Okay, now again, I want you to think, what's pi? Pi is what, 3.14? Okay, if I take 2 minus 3.14, is this value going to be positive or negative? It's going to be negative, right? So I'm going to have the absolute value bars of a negative number. But I need the positive answer, so I've got to multiply it by a -1. I got to multiply what's on the inside by the -1. So in other words, if I take -1 times whatever was in that inside part, it's going to give me my positive answer, which is what I want. So I'm going to take -1. I'm going to multiply it by 2 minus pi. Because this is a negative number times this. All I'm doing is changing the sign, which is what I want to happen. So distribute that. What, I get a -2 plus pi? I could rewrite that pi minus 2 if I wanted to clean it up a little bit, but there's nothing wrong with that. Okay. pi minus 2, either one. All right, this is a little cleaner, but that's the same thing. So if you've got some expression inside that absolute value bar, determine whether it's positive or negative. If it's positive, all you got to do is write it down again. If it's negative inside there, you've got to take it and multiply it by -1 just so you're changing the sign. Okay, so you've never done, up to this point, you have not done absolute value like that. Okay? All right, so all good? Okay. When I go all good, are we all good? That also means for everybody at home too. All you guys have to do at home is like turn your mic on and go, hey, don't understand something, got a question. And then see, this is what you guys, like, I tried to get the freshmen last block to talk to me. They wouldn't do it. I literally had to pick on people. Open your mic, talk to me. But seriously, if you're at home and we're doing this and you're in the Zoom meeting and you've got a question, unmute your mic and start talking because I've got the sound up on the laptop, so we're all going to hear it. Okay. Okay. Last thing, I just want to do one example. Okay. Because again, this is an easy concept. You have done this a lot in Algebra 1. You have done this a lot in Algebra 2. So let's run a simplifying expressions here. And of course, they're not going to be easy ones because this is a pre-calc book. So they are going to be more challenging than what you have done in the past. All right. You are going to have to follow order of operations. So you've learned it a million different ways. But what? Please excuse my dear Aunt Sally. PIMSDA. Some people call it that. Whatever you want to call it. Okay. I am going to do one. We're gonna do like one of the hardest ones where you're most likely going to drop a negative. All right, because I want you to catch dropping the negative. I don't want that to happen. All right, so I don't know. Let's do something like 10 minus 2 square bracket 8 plus. No, let's not make that a plus. Let's make this a little bit more challenging. Let's make that a minus. All right, let's throw a minus in there. And then 2x plus 4, the square bracket. Okay. All right, so I've got a lot of minuses in here, and I've done this on purpose, okay? Obviously, you got to work on the inside out. We're going to combine some like terms. All right, this is the inside most set of parentheses, but there's a minus sign that's in front of it. Distributive property, distribute that negative through there, go through and change all the signs. Now, you should have nice lines of algebra going down. So you need to bring that 10 straight down. I'm not doing anything with it. The minus sign needs to come straight down. The 2 needs to come straight down. All right, 8 needs to come straight down. Now I'm going to distribute that negative. I'm going to go through and I'm going to change those signs. So minus 2x minus 4. I'm still going to work inside those brackets, right? Because I got to combine some like terms here. 8 minus 4. 8 minus 4 is going to give me a 4. And in all honesty, at that point, it doesn't matter whether you put the 4 in front or the 4 in the back. I'm going to keep the 10. I'm going to keep the minus. I'm going to keep the 2, the set of brackets. All right, I'm going to go ahead and put it in front. 8 minus 4 is 4. Then I still have the minus 2x. Now, how many people want to do 10 minus 2 and get an 8 out in front? Trick question. Order of operations. Do I still have to work inside? The number one mistake right here, and I kind of have written this so there's a lot of gap here, but if there's not a lot of gap there, a lot of people want to do 10 minus 2 and write down an 8 right here, and then bring down that set of parentheses. All right, however, you're not following order of operations, okay, because multiply has to come before and subtract. Right there, that 2 is being distributed or multiplied. All right, so you've got to do this multiplication before you do that subtraction. Okay, so, and it just, this is like, I'm not kidding, this is like everybody wants to take 10 minus 2 and put an 8 down here in front. Okay, so try to refrain from doing that. Keep that 10 there. Distribute the negative 2, which will make this what, a negative 8? All right, so minus 8. And then a negative 2 and a negative 2x, positive 4x. Don't let me screw up. 10 minus 8, it's going to give me a 2. So 2 plus 4x. So you just have to be really, really careful. All right, you have done this for a long, long time. You should be real good at it. You're going to make mistakes. when you drop negatives, when you forget to distribute something, and when you make silly mistakes multiplying. Okay? All right, now, actually, that was a lot of different stuff, right? What you're going to find and you're going to discover in this pre-calc book, all right, there are a lot of different topics in just one section. All right, it's more like a college textbook. There is a lot of information in one section. Okay, so today, because it was all review and I thought you could handle that many different topics. All right, later on when we get into harder stuff, all right, we might take 2 days to do a section. All right, because we'll slow down a little bit because the concepts are going to be a lot harder. But this P chapter, I'm going to go through it relatively fast because at this point you should have all of this. The chapter P is a review chapter, so it should be mastered at this point. Okay, but since it's been a while, since what, March, since we've been in school, I thought we'll go through this chapter P just to kind of get back in the swing of things. Okay, are we good? Okay, so for everyone, whether you're at home or whether you're here in school, all right, you're going to look, you're going to check your email, check Google Classroom, check the calendar. All right, the calendar, you're going to do a book assignment for the first time. So you're going to have to go out to the website, click on chapter P, download the textbook. It's going to be in PDF form. It'll need a password. Okay, so we all know what the password is, right? I don't want to say it in the video because if I upload this to YouTube, I don't want to say it in the video. All right, our school name, all lowercase. Okay, and then you're going to show all your work on a piece of paper. You'll take a picture of it. You'll turn it to a PDF and you'll upload it to Google Classroom. Okay. All right, I think I'm going to go ahead and stop the Zoom meeting. Is everybody home good? Are we all good? You're not asking me any questions? So I hope so. Sarah, are you all good?
Yeah, I'm good.
Okay. Helena, how about you?
I'm good.
All right. Brody, you still with me?
Yep.
Oh, hey, that's good. Kind of sound sleepy, but you're there. All right. Miss Heron, how about you? Close enough. All right, I'm going to end the Zoom meeting, guys. So I'm going to stop sharing. I'm going to end it.